So our last class is today, and hari ni pun last raya. Okay, last bulan Syawal, esok dah masuk Zulkaidah. Alright, so macam Cik cakap semalam, hari ni kita akan start with the new chapter. Okay, new chapter, heat. Right, sebab dia korang masuk sekolah ni tak silap cikgu akan ada exam. Okay, so kita try to recap every subtopic, every topic in form 4 daripada chapter 2 until chapter 5 lah. But our susunan tu kita tak follow susunan yang macam 1 to 3. Kita start 5, 2, 3 and 4. So chapter 1 je kita tak buat. Hopefully korang okay lah kot chapter 1. Hopefully. Okay. So start with the new chapter today. Heat. Siapa lagi yang tak ada ni? Sekejap 18 je ni. Harisa. Oh, Harisa dah ada. Okay. Maira, Julia bermasuk. Maira ada tak? Ada. Okay. Tak apalah. Okay. So, start with this chapter, heat. Kita pergi pendek je. Thermal equilibrium. Thermal equilibrium, 3 important thing that you need to remember about thermal equilibrium. Okay, siapa boleh bagi tahu 3 perkara kalau cakap thermal equilibrium, 3 perkara ni tak boleh lupa. Apa dia? Okay,
Net force equals to 0.
Net force.
Apa? dah lupa.
Net tu dah betul dah, tapi bukan net force.
Net
rate.
Net rate
Net.
of heat flow. Oh, tu campur dah. Okay. Net rate of heat flow equals to 0. Okay, so number 1. Number 2, apa lagi? Heat flow or heat transfer is same. Okay, maknanya kalau kita ada dua objek. Okay, dua objek, contohnya gini. A and B. So A transfer heat. Remember, heat is energy. 100 joule, for example. So B will also transfer 100 joule. So the heat flow is the same. Net is 0. Net is 0 because 100 to the right minus 100 to the left, you get 0 joule. Okay. And last one is the temperature will be the same. So after reaching thermal equilibrium, contohnya this one is 30 degrees Celsius, this one also 30 degrees Celsius. Okay. Tapi previously, before reaching thermal equilibrium, maybe it is something like this. This is 50 degrees Celsius, this is 20 degrees Celsius, and yang panas pindahkan lebih, for example, 80 joule. Yang sejuk pindahkan sikit, 20 joule. Okay, this is heat transfer. After some times, it will reach thermal equilibrium. Okay. You just need to focus during thermal equilibrium, which is what happened during thermal equilibrium. 3 things that you need to remember. Sama, dia punya temperature sama. Okay. Heat flow dia sama. Net heat transfer is 0. Okay, next one. So kita pergi soalan terus. Diagram 2 show identical metal disc M and N in contact. Initial temperature of N is 60 and 20. Okay, so satu panas, satu sejuk. So basically, yang panas akan transfer more heat. Sejuk akan transfer but less heat. Okay, because this is only 20 degree. So any transfer less, any transfer yang biru tu transfer more heat. Okay, which statement is correct about M and N when dia fokus dia dekat soalan ni, dia akan fokus kepada thermal equilibrium. Okay, cari je 3 perkara tu. Temperature higher, no. Higher, no, because temperature in thermal equilibrium is the same. Net rate of heat flow is not zero. Not zero. Should be zero. So jawapan dia adalah net rate of heat flow between M and N is zero. So the answer is D. Donkey. Okay. Alright. Okay. Number 2. A cake is placed in a hot oven. The temperature of a cake is the same as that of the oven after several minutes. Okay, sebab tu after several minutes. Okay, sebab kalau kita baru masuk kek, waktu tu belum lagi thermal equilibrium. Masukkan kek, what happen is waktu tu tengah berlaku heat transfer. So that cake will absorb the heat from the oven and the oven will give the heat to the cake. The transfer. Okay, so bila dah capai thermal equilibrium, okay, so apa yang jadi? Dia capai thermal equilibrium lah. Right. Latent heat, vaporization, latent heat of fusion. So what is the difference? Lalang dia ada kat sini. Ni topik 4.3. Okay, apa beza? Latent heat dengan specific heat. Recap balik.
Latent heat dia change forms.
Change form, okay. Dia tepat sikit kalau kita kata change state. Okay, so kat sini dua-dua ni. Change state of matter. Okay, meaning the heat is absorbed for the purpose of changing its state. Okay, kalau vaporization, tukar state daripada apa? Okay, kalau vaporization, meaning is changing state from liquid
to gas.
to gas. Okay, cikgu buat macam ni lah, LG. Liquid to gas. Okay, and then latent heat of fusion is from solid to liquid or liquid to solid, same thing. The difference is if liquid to gas, it will be latent heat of vaporization being absorbed. Okay, kalau gas to liquid, it will be latent heat vaporization being released. Okay, same thing with specific latent heat of fusion. Okay, latent heat of fusion absorb from solid to liquid, and latent heat of fusion release from liquid to gas. Okay. So change state, apa yang kekal? Yang kekal adalah temperature constant. Okay, temperature is constant. Okay, how about specific heat capacity?
Temperature change.
Yes, temperature change. And then, how about state? State remain constant. Maksudnya, solid kekal solid. Liquid kekal liquid. Only the temperature of the solid or the temperature of the liquid change. Okay, itu saja.
Cikgu.
Yes.
Kalau contohnya kalau objek tu dia undergo sublimation, dia dikira sebagai latent heat of apa?
Sublimation. Okay,
Ah,
sublimation means tu dia escape semua lah. Maknanya dia maknanya kalau terus dia lain lah nama, bukan lain nama. Maksudnya dia ada dua dia terus dia macam cakap dia macam skip kan. So bila dia skip sublimation. Special name tak ada pula. Yang tu tak ada special name. Nanti cikgu check yang tu. Dia tak ada special name. Tapi basically the amount of heat yang dia require lagi besar lah. Okay. Lagi besar. Cuma tak tahu dia punya nama. Okay. Nanti cikgu check. Good question. Menarik kat tu. Sublimation. Okay. So korang jangan ni dengan benda ni. Dengan the process. Okay. Ni nama dia punya. Ni tahu macam cakap This is the name for the heat. Okay, kalau dia absorb for the purpose of changing state or dia release for the purpose of changing state, it will be latent heat. Okay, kalau dia absorb or release of heat for the purpose of changing temperature, kita panggil dia latent heat capacity. Okay, so kalau proses dia macam ni. Proses tu macam ni. Ni solid, liquid, gas. Okay, proses Kalau solid pergi liquid, ni dah lama belajar ni. Solid pergi liquid kita panggil apa? Lalu kita panggil melting. Yes, melting. Liquid pergi gas. Kalau liquid pergi gas?
evaporation.
Vaporization. Okay. Gas to liquid?
Condensation.
Condensation. And liquid to solid?
Freezing.
Okay. Sublimation tu yang mana?
Solid to gas, gas to liquid gas to solid, solid to gas.
Yes, solid to gas. Okay, macam tu. Atau solid to gas atau gas to solid, kita panggil dia sublimation. Okay. Tu proses. Itu proses tau. Kalau nama heat dia yang ini. So, untuk maksudnya, kalau maksudnya contoh for melting. Okay, melting. So, kita melting mana? Melting solid to liquid. Okay, heat dia specific latent heat fusion. Okay, sama juga kalau dia kata condensation. Okay, condensation gas to liquid. So, gas to liquid yang mana? Gas to liquid latent heat vaporization. Okay, lepas tu being released ke being absorbed? Because gas to liquid, so it will be specific latent heat vaporization being released. Itu yang dia punya konsep kena faham. Okay. Alright, so next one. Diagram 13 show two beaker with different volume of liquid X and same initial temperature. Both beaker are heated with the same amount of heat. Okay, so apa yang different is different volume. So that will be the manipulated variable. Initial temperature is the same, constant. Amount of heat being supplied also constant. Okay. Kat sini, ini sebenarnya bukan dah thermal equilibrium tapi tak apa. Okay, so here we have low volume. This is higher volume. So logically speaking, mestilah yang dia ni low mass. Because the same liquid. Okay, same liquid. This is low mass. This is high mass. Or bigger mass. Okay, so the changes is in mass. But it's okay, kita tengok apa dia punya ni. So dia punya initial temperature dia kata initial temperature. Both vehicle are then heated with the same amount of heat. Okay. Okay. So dia pun supply same amount of heat. Q equals to mc theta. Q equals to mc theta. Okay, kenapa cikgu pakai mc theta? Okay, kenapa cikgu pakai specific heat capacity, not a latent heat?
Sebab there's a temperature change.
Yes, sebab ini temperature change. And dia tak kata pun liquid tu jadi gas. Okay, apatah lagi dia jadi solid. Tak boleh jadi solid because you heat up a water. Heat up a water confirm sama ada dia kekal liquid or dia become gas. Takkan kita heat up water tiba-tiba jadi ice pula. So tak boleh. Okay, so dia changing the temperature. Okay, so the amount of ni sama. Oops. Okay, so surely dia punya C sama. Specific capacity because same liquid. This is same liquid. Okay, it is the same liquid. And mass is different. This one lower mass. This one bigger mass. Okay, so heat is also the same. Okay, dia kata sama. Okay, so sama kat situ. So dia nak kaji apa tu? Mass and theta. Okay, so mass and theta. So mass and theta, what is the relationship between mass and temperature change? So rearrange Q over M sama dengan C theta. Sama juga rearrange Q over M sama dengan C theta. Okay, what will be the relationship between mass and theta? Apa relationship dia?
Inversely proportional.
Inversely proportional. Okay, so basically if the first beaker has lower mass, so lower mass temperature change will be higher. So theta dia higher. Okay, second one, theta dia will be lower. Okay. The question is, so kalau theta dia higher, temperature change dia banyak, so what happen to the thermometer? Thermometer dia akan naik lagi besar. So the answer will be ayam. Okay. Kalau kita tengok yang kat situ memanglah. Contoh gambar, temperature dia sama. Okay. Tapi kalau dia dah heat up, so dia akan different. Okay, next one, number 4. Still thermal equilibrium. So, sup 95. Apa yang tak mandi ni? Cikgu sampai bau kat sini ni. Okay, so 95. Which statement is correct about thermal equilibrium? Kita cari. Cari je jawapan 3 tu. Soup unchanged salah, spoon unchanged confirm salah. And no flow of heat between soup and spoon has the same temperature. Okay, so mana nak ambil? C ke D?
D.
Okay, why C salah? Okay, What is meant by no flow of heat? Okay, ni term yang selalu student pun tersilap guna. No flow of heat. Dia kalau nak tepat adalah no net flow. Net. No net flow of heat. Okay, apa beza dia? No flow of heat maksudnya ni sudu. Ni sup tadi. Okay. Mangkuk dia. Sudu ni transfer kosong joule. Sup ni transfer pergi sudu kosong joule. Ini baru maksudnya no flow of heat. Okay. Different. No net flow. No net flow maksudnya macam ni. Ni sudu. Mangkuk. Okay. So, dia transfer contoh 100 joule. Sup transfer 100 joule. Okay. Ni ada flow of heat. And also net flow of heat is 0. Okay. Dapat?
Dapat.
Okay, so cikgu harap in paper tu korang tak buat lagi kesilapan yang sama, yang lazim. So this is lazim. Lazim selalu orang buat. Okay, no flow of heat. No flow, salah. Bukan no flow of heat. No net flow. Baru betul. No net flow of heat ataupun net flow of heat is 0. Sama je maksud dia. No net flow of heat, ini sama maksud dengan net flow of heat is 0. Okay, maksud dia sama. Alright. So diulang balik 2015 tapi tak ada gambar sup. Diulang balik cuma dia tak ada gambar sup. Yang ada dia tulis hot soup is put into a bowl, which statement is correct about the heat flow. Okay, so net heat flow. Tapi soalan ni pun sebenarnya tak berapa lengkap sebab dia tak tanya, dia tak beritahu pasal thermal equilibrium. So soalan ni sebenarnya tak berapa nak lengkap. Okay. So sebab selalunya dia memang akan letak ni thermal equilibrium. So thermal equilibrium, the answer will be net heat flow is 0. Okay, net flow is from hot soup to the bowl, salah sebab dia bukannya pada soup kepada bowl je. Bowl pun transfer juga. Okay, heat flow only from bowl to the soup lagi salah because both will transfer heat. Okay, kalau benda sejuk pun dia transfer juga tapi dia transfer sikit. Okay, kena faham kat situ. So benda yang panas campur dengan benda yang sejuk, bukan yang panas je transfer pada yang sejuk. Yang sejuk pun transfer pada yang panas. But the amount of heat is too small. Okay, so tu sebab A, B, C salah. Okay, nombor 6 dia masuk pula hot coffee is left to cool until it achieve room temperature, maknanya thermal equilibrium. Which statement is correct about the coffee and room temperature? Okay. Heat loss by the hot coffee is equal to the heat loss by the surrounding. Okay, kalau yang betul, it's heat loss by the hot coffee is equal to the heat gain by the surrounding. Okay, heat loss by the hot coffee is less than the heat gain by the surrounding. Okay, ni salah. Thermal equilibrium, it should be the same. Heat loss by the coffee is greater than heat gain by the surrounding. Okay, ini pun Salah, it should be the same. Okay, heat loss by hot coffee is equal to the heat gain by the surrounding. Okay, ingat thermal equilibrium ada 3. Temperature is the same heat transfer. Same heat transfer yang ni lah. Ini maksudnya same heat transfer. And net heat transfer is 0. Okay. Last one for thermal equilibrium. Hot metal bulb is immersed in water at a temperature of 30 degrees Celsius. If the initial temperature of the metal bulb is 60, what is the temperature of water when thermal equilibrium is achieved between the metal bulb and water? Okay. So yang kat sini dia tak suruh kira. Kalau trial dia akan suruh kira. Tapi yang ni tak suruh kira. Dia cuma bagi tahu macam ni. Korang buat line to representing temperature. Okay, so suhu paling kecil is 30 degrees Celsius. And this is the temperature representing the water. And suhu paling panas is 60 degrees Celsius, which is temperature of the bulb. Okay, so the final temperature will be in between, tak tahu berapa. Okay, tak tahu berapa. So if, ni cikgu bincang terus kalau contoh trial. Okay. For example, katakanlah water tu we have, for example, ni example je, mass of water, kita letak, berapa nak letak? Okay, cikgu ambil korang punya cadangan. Mass of water berapa nak letak?
20 grams.
20 gram uyuh. 20 gram.
Kan?
Okay. 1 liter, 1 kg. 1 liter air, 1 kg. Sebenarnya kalau korang minum air yang botol mineral besar tu, tu 1.5 kg. Okay, so kalau kau 20 gram tu kecil sangat tu. 20 gram tu berapa titis je. Okay, ambil senang lah. Ambil itu 500 ml. Okay, 500 ml. So, kalau 500 ml, volume dia, ni volume 500 ml, kalau untuk mass, dia bersamaan dengan untuk water, it will be 0.5 kg. Okay, bolehlah. 0.5 kg. Ni satu mineral water kecil. Okay, dia tuang dalam bikar. And then, besi tu, berapa kg? Bob.
1.
The metal bob, 1 kg. Okay, 1 kg. Alright, assuming the metal bob, metal yang dia guna adalah gold. Contohlah. Gold 1 kg. Wow, kaya siut. Okay, gold berapa specific capacity dia? 300 joule per kg per degree Celsius. And for water, specific capacity of water is 4200. Okay, ni cikgu buat soalan lain. Sebab soalan macam ni selalunya keluar trial. Macam tu. So dia tanya find the final temperature. Okay. Kalau macam soalan ni, soalan SPM ni senang. Mana temperature dia? Temperature dia mesti between. Okay, jawapan dia temperature dia between. Tapi berapa nilai between tu? Kita boleh cari. So macam nak cari? Kita guna formula macam ni. First, buat garis. Letak the smallest temperature at the end, belah kiri. The highest temperature at the end, belah kanan. And put the information. Yang lower temperature tu siapa? Dalam kes ni, the lower temperature is water. The higher temperature is a bulb. So ambil maklumat lain. The mass, the specific heat. Okay, and kita nak find X. Okay, macam mana kita nak kira? Water akan buat apa? Water akan gain heat. Okay, water akan gain heat. While the bulb will releasing heat. Okay. So bulb tu akan, dia lebih ada heat loss. Okay, bila thermal equilibrium, heat gain akan sama dengan heat loss. So the formula will be MC theta MC theta. Okay, kenapa cikgu nak ajar ni? Sebab cikgu nak ajar yang temperature ni. Temperature ni selalu ramai buat silap. Okay, untuk water, theta will be X minus 30. Okay, untuk Bob, the temperature will be 60 minus X. Sebab kita tengok perubahan. Nak tengok perubahan, ambil besar tolak kecil. So for water, X is bigger than 30. So X tolak 30. For the Bob, 60 is bigger than the X. X is the final temperature. Okay, final temperature. And final temperature dia kena sama. So kita masukkan nilai 0.5, 4200, X tolak 30. Ini 1 kg emas kau. 1 kg emas harga hari ini bersamaan 250,000. 1 kg emas. Okay, so darab 2100 darab X tolak 30. 30 darab 60 tolak X. Okay, persoal algebra. Okay, algebra jangan salah matematiknya. Kumpul X.
Cikgu, saya rasa cikgu dah salah dah.
Cikgu salah kat mana?
Specific heat capacity untuk Bob is 300 not 30.
300. Cikgu saja buat salah. Nak tengok korang perasan ke tak. Thank you. 300. Itulah, tegur orang salah, cikgu buat salah. Okay, itu menunjukkan apa? Cikgu juga manusia, tidak sempurna. Cik, wah. Okay, so 300 darab 60. 18,000 tak? Ke cikgu salah kira ni? Ni pun
Betul,
salah ni.
18,000.
18,000. Tapi yang sini salah. 2,100 darab 30. 63,000.
Yes.
Tambah lagi lah. Okay, ni tambah 63,000. So sini akan tambah jadi satu lagi kosong. Kosong. Okay, so dapat berapa?
Cikgu, it's 2,400x.
2000. Oh ya, ni 300 X 300. Okay, sorry, 2,400. Tak ada calculator. Ginilah dia. Okay, anak cikgu dah buat telefon dah buat main. Okay, berapa dapat?
33.75.
33.75 degree Celsius. Itulah final temperature dia nanti. Okay, so kalau korang kena jawab macam ni dalam trial, so I hope you know how to do it. Okay, selalu trik dia yang ramai akan silap dekat first start mula-mula tu. Start mula-mula tu buat dulu line and letak suhu paling sejuk, suhu paling panas kat ujung. Sebab dia punya final temperature mesti tengah-tengah. Tengah-tengah tu maksudnya bukanlah kalau 30, 60, oh final temperature dia 45. Tak, bukan macam tu. Dia kira-kira. Okay, kena kira because it depend on specific heat capacity. Okay, so ni cara kira dia. So korang dapatlah yang air tu tak adalah dia naik panas sangat. Dia hanya naik Daripada 30 dia jadi 33.75. Itu example-nya. Okay, any part yang korang nak salin, cikgu tunjuk kejap. Okay. Right. Okay. So boleh? Okay, ada soalan nak tanya untuk yang ni? Ada tak clear ke kenapa cikgu letak macam tu?
Tak ada.
Okay, tak ada. Alright, so cikgu teruskan. Next question. Number 8. So dah start dengan 4.2 which is specific heat capacity. So specific capacity, ingat balik tadi cikgu dah tulis kat atas juga, it is used for the heat is absorbed or released just to change the temperature. Okay, contoh kat sini, dia nak change temperature from 30 to 55. Temperature apa? Temperature of metal block. Okay, secara logiknya pun kita boleh fikir yang metal block from 30 to 55 takkanlah dia melt. Dia tak melting. Because kalau metal dia ada temperature dia baru dia boleh melt. Which is higher lah, higher temperature. So ada yang akan melt kalau pada suhu 500 degree Celsius baru melt. Okay, so macam case ni dia tak ada melt lah. Maknanya dia hanya changing temperature. So bila changing temperature, the only formula that you use will be Q equals to MC theta. Okay, so kita ambil maklumat dia. 17,600 joule. So 17,600 joule. Inilah heat. Q is used to increase the temperature of 800 gram. So the mass 800 gram. Okay, 800 it will equal to 0.8 kilogram. Jangan lupa tukar. Okay, so next one. What is the specific capacity? So the question asking you about the value of C and the theta. So berapa theta dia? Bigger tolak smaller. 25. Okay, so kita cari. Masuk dalam formula. Rearrange the formula. C equals to Q over M theta. 17,600 joule over 0.8 kg times 25. Okay, so 0.8 times 25.
180.
180. 880.
880.
Okay, so 880. Joule, kg kat bawah, ni atas. Degree Celsius kat bawah, ni atas. Okay, so tu specific heat. Okay, sorry, cikgu sesama. Okay, next one. Which phenomena show the application of specific heat capacity? Ini ramai juga yang confused ni. Okay, mana satu? Okay, raksasa mana satu? Okay, so korang punya okay, yang mana satu korang rasa? Yang gunakan specific heat capacity. Meaning it based on specific capacity lah. Kenapa dia digunakan? Because of specific capacity. Okay, first one, steaming fish. B ke cikgu? Yes, jawapan dia B, betul. Okay, tapi kenapa kita tengok dulu salah satu, steaming fish. So macam kita nak steam fish, maksudnya kita letak ikan and ikan tu dia masak, dia absorb heat daripada mana? Dia absorb heat dari steam. Maksudnya kita panaskan air, air dah jadi panas kan. And then that heat daripada wap tu pergi ke ikan. And ikan akan absorb heat. And sampailah dia dah masak, waktu dia masak sebenarnya dia dah capai thermal equilibrium. Dia sama macam buat kek, tu semua thermal equilibrium. Okay. Cooling down a coffee pun thermal equilibrium. Pouring coffee into coffee maker, yang tu cikgu tak tahu. Rasa tak ada apa-apa, letak kopi je. Letak kopi, okay. Tak ada effect apalah. Belum ada konsep lagi. Belum ada kaitan dengan heat lagi. Sebab kita baru letak kopi, baru letak je. Tak ada apa-apa pun. Okay, it's cooling a car engine because kita letak apa? Kita letak water. Which is water has high specific heat capacity. Okay, so bila dia besar, dia lambat panas and dia akan store more heat ataupun big amount of heat from the engine. Okay, and air tu pula akan disejukkan balik oleh radiator. So air tu jadi sejuk balik, pergi balik ke engine. Okay, that's B. Okay. Go to the next question. Okay, at night, land cool down faster than the sea. Okay, land cool down faster than the sea. Which statement explain the situation? Okay, kenapa? Sea absorb heat more than the land. Okay, the breeze blow from the sea to the land. Specific capacity of the sea water is greater than the land. Kenapa daratan cepat sejuk?
C ke cikgu?
Sea, the breeze blow from the sea to the land during night. Okay, terbalik tu. Kalau blow from the sea, okay, dia macam ni. Ni cikgu kena cerita balik. Satu land breeze, and another one we call it as sea breeze. Okay, cuba tukar sikit lah. Sebab itu buat siang malam senang. Sea and then land. Okay, kalau sea, dia berlaku waktu siang. Okay, waktu siang, katalah ni ada air, sini darat. Okay, ni pokok. Sekejap. Alamak. Okay. Satu lagi. Land. Okay. Ni waktu malam. Pokok untuk padam. Pokok. So malam ada bulan. Macam mana aku nak lukis bulan? Bulan. Gitu boleh lah tu. Okay. Okay, contoh. Okay, so cerita dia gini. Wih, cantik pula rasa. Okay, so cerita dia, sea breeze ni. Okay, ni waktu siang. Kenapa waktu siang? Waktu siang, ni. Land, low specific heat. Okay, water, high specific heat. Okay, so apa jadi next? Land heat up faster than water. Okay, so maksudnya kita akan dapat water ni lebih sejuk, land ni lebih panas, hot. Okay, so apa jadi? Hot air pergi mana? Hot air from the land going up. Okay. Lepas tu, cool air from the sea blow to the land. Okay, so nama dia sea breeze. And berlaku waktu siang. Okay, sea breeze berlaku waktu siang. Okay, so kalau macam jawapan C ni, the breeze blow from the sea to the land during night, tu salah dia. Dia sepatutnya during day. Okay, during day. The answer is D. Specific capacity of sea water is greater than the land. Okay, cuba kalau kita nak cerita pula land breeze. Okay, siapa nak cuba land breeze? Cikgu bagi gambar sebelah tu sebagai rujukan. Okay, cuma bezanya waktu malam, absorb heat atau release heat? Okay, so yang mana satu? Macam siapa yang nak cuba? Kita nak cerita mana dulu? So sea breeze tu maksudnya angin sejuk tu daripada sea. Kalau land breeze, angin sejuk dari darat. Okay, ada yang cuba? Alright, ada yang cuba. At night, land lost heat faster than sea. Okay, good. Betul? Okay, during night atau at night, land lost heat faster than sea. Okay, betul. Cikgu salin. At night, land loses heat faster than sea. Okay, betul? Mana hot air, mana siapa hot, siapa cool. Okay, so kita cerita hot air dulu. Hot air. Okay. On the water goes up. Okay, cool air from the land blows to water. Okay. So barulah berlaku land breeze. Okay, that's the difference between land breeze and sea breeze. And this is based on specific heat capacity. Okay, so kalau macam tadi, engine, car engine, specific capacity. The natural phenomena related to this is land breeze and sea breeze. So kat sini, yang panas ni daripada laut naik ke atas, hot air, and cool air daripada darat. Okay. That's why pokok dia tu arah lain. Satu bergoyang ke arah darat, satu bergoyang ke arah laut. Okay, thank you for those yang cuba. Siapa ada apa-apa lagi bahagian ni yang tak faham, yang tak clear? About land breeze and sea breeze. Okay, so kena ingat tau, yang ni kena ingat. Especially for paper 2. Okay, the answer is donkey. For this one, the answer is donkey. Okay, we go to the next one. Okay, diagram show an apparatus set up to determine the specific capacity of aluminium block. Okay, yang ni kena ingat ni paper 3. Arrangement for paper 3. So you have an immersion heater, you supply the heat kat dalam ni. So ni ada power supply, immersion heater. So kalau immersion heater, the heat is absorbed from the heater. So now the heat kita ganti dengan PT. Okay, PT is power of the heater. P darab dengan T, time. T kecil. Alright, and then we have a thermometer to measure the temperature change. Okay, and aluminium block. Okay. So this is from the experiment. Which step cannot increase the accuracy of C? Okay, macam mana dia nak kira C kat sini? So dia kira C. Dia guna, asalnya ni PT equals to MC theta. So dia guna C, dia kira C based on power supply, time with the heating time over mass of aluminium block time the temperature change. Okay, temperature change ni kita tengok thermometer. Okay, mass ini kita ukur mass of the block berapa. And then power ni, power supply. And time kita tengok stopwatch. So kita measure dia punya heating time. Okay, heating time. So sekarang ni kita nak dapat accurate value of C. Okay, how to get accurate value of C? First, kita kena make sure that the heat supply do not or less loss to surrounding. Okay, because if the heat is lost, you require more heat nak bagi dia increase temperature. So kita tak nak dia loss. So macam mana kita tak nak dia loss? Pertama, kita buat yang ni. Wrap the aluminium block with cotton. Purpose dia to prevent the heat loss to surrounding. Okay, wrap the aluminium with cotton to prevent the heat loss to surrounding. Okay, put the aluminium block on the polystyrene sheet. Maksudnya yang ini jangan letak atas meja. Okay, jangan letak atas meja. Aluminium block ni belah bawah dia ni, belah bawah dia ni letak dengan polystyrene. Okay, so dia tak letak atas meja, dia letak atas polystyrene. Kenapa? Polystyrene sheet is an heat insulator. Heat insulator. So tengok kalau macam orang main sukan ke apa kan, dia bawa ais dalam bekas apa? Bekas polystyrene. Okay. Cover the top of aluminium block with aluminium foil. Okay, ni tak. Yang ni jawapan dia lah. Sebab dia tanya which one is cannot increase. Sebab apa? Aluminium foil will absorb heat. Okay, pour some lubricant oil into the hole where the thermometer is insert. Ni thermometer ni dia masuk dekat lubang. Dalam lubang ni letak minyak sikit. Okay. Yang ni betul. Ni tujuan dia adalah to increase the sensitivity of thermometer. So itu tujuan untuk D. Okay. Okay. Alright, ada sebarang soalan untuk yang tu?
Ada.
Tak ada. Itu metal block of same mass. Kita pergi soalan nombor 12. Heated simultaneously with identical heater. So ni sebenarnya nak beritahu identical heater ni maksudnya dia nak beritahu oh dua-dua ada same power. Okay, lepas tu after 15 minutes the temperature of metal block is higher. So time dia sama. Okay, P and Q higher than temperature of P. Okay, so the temperature of Q is higher than P. Which comparison is correct? Okay, same as, so masuk formula balik. PT equals to MC theta. So ini cikgu harap korang cekap benda ni. So ni korang akan pakai dalam semua bab. Okay, so same power, cikgu gariskan, same power constant, same time 15 minute constant, same mass constant. Okay, so dia bagi tahu the temperature of Q higher than P, maknanya ada dua blok berbeza. So it will be PT over C sama dengan M theta. What is the relationship between theta and C? Inversely proportional. So siapa yang ada higher temperature change, higher theta, C dia rendah. Okay, so dah kat sini, the temperature of Q is higher than temperature of P. Okay, maknanya theta untuk Q higher. Jadi Q ada low specific heat. Okay, theta untuk P is lower. Jadi P ada higher specific heat. Okay, so specific heat of P is higher than specific heat of Q. Okay, jawapan D. Okay, jawapan okay. Thank you Alia. Jawapan D. Alright. So B ni salah. C ni tak boleh pilih, D pun tak boleh pilih. Kenapa? Kenapa cikgu tak boleh pilih C dengan D?
Latent heat.
Dia latent heat. So, kalau latent heat, kenapa tak boleh pilih latent heat? Macam sebab because latent heat changing state, not changing temperature. So changing temperature, specific heat capacity. Okay, 13. Show 1 kg of liquid being heated using electrical heater for 10 minutes. Okay, so sama juga masa 10 minit, the temperature of liquid is increased faster by. Okay, kita nak temperature dia increase faster. Maksudnya dia nak cerita apa? So masuk kat sini, PT equals to MC theta. Okay, apa yang dia nak kaji? Bila dia kata faster tu, which physical quantity yang dia nak measure? The temperature increase faster. Dia nak ukur temperature ke dia nak ukur time?
Temperature.
Okay. Liquid increase faster. The temperature of liquid increase faster. Nampak macam dia nak ukur temperature. Tapi bila dia kata faster, maksudnya dia nak tengok macam mana kita nak bagi time ni shorter time. Okay, shorter time maksudnya kita nak time ni rendah. Kita nak time ni singkat. Okay, so apa yang kita boleh ubah supaya time tu jadi lagi singkat? Okay, kalau using, okay, contoh kalau kita ambil A. Using liquid with higher specific heat. Okay, so kalau kita ambil tu, PT equals to MC theta. T dengan C. Okay, higher specific heat. Apa jadi kepada time?
Increase.
Increase sebab dia satu baris. Okay, kiri kanan sebaris, dia directly proportional. Okay, so tak boleh. Reduce the time. Okay, so kalau reduce the time, apa pula dia nak time reduce the time? Okay, so reduce the mass. PT MC theta. Okay, time dengan mass. Kalau mass tu sikit, time pun rendah. Okay, tu jawapan dia. Sebab keyword dekat situ dia nak increase faster. Alright, any further question untuk yang ni? Ada soalan tambahan?
Tak ada.
Okay. So 2014-21 diagram show a pot. Okay, so dia tanya why is the pot handle made of high specific capacity? Kenapa pemegang tu buat daripada material yang higher specific capacity? Okay, apa jawapan korang? Yes, to reduce the increase in temperature. Sama juga, Q equals to MC theta, relationship between C and theta. Okay, so dia sebelah-sebelah, tak boleh, so kena pindah. Q over C, M theta. Okay, C kat bawah, theta kat atas. Higher specific heat, so temperature dia tak ubah banyak. Dia tak panas, kita boleh pegang. Okay, next one. Masih lagi cooking pan. Which specific capacity value of material is suitable to make the handle, the body, and the base? Okay, handle, body, and base. Okay, handle. High or low specific heat?
High.
high, body and base both kena low. So jawapan dia A. Okay. Right. Masih lagi pen. Tengok belakang pun soalan pen lagi. Okay, so ni. Two different type of metal block X. Different Kenapa nak beritahu different? Different bermaksud we will have different specific heat capacity. Okay. Same mass, heated with same amount of heat. The rate of temperature rise, metal block Y is slower than X. Okay. So Q equals to MC theta. Same amount of heat, same mass. Okay, so C and theta sama macam tadi. Higher C, lower theta. Okay, so the rate of temperature rise, metal block Y slower. Okay, so Y dengan X, Y theta dia kata slow. So theta dia rendah. Ini higher lah. Okay, then so lower theta, higher C. Higher theta, lower C. Okay. Specific heat capacity of block X smaller than Y. Okay. Right. So next one. Bottom surface of pen. Okay, nak ambil yang mana? What is the suitable characteristic of material used as the bottom surface of pen? Low specific heat capacity, easily heat up. Theta will be higher. Yay, latent heat dah. Okay. What occur during melting? When solid of naphthalene to liquid. Ubat gegat. Siapa pasang ubat gegat kat rumah dia?
Saya.
Okay, tu ubat gegat. Nama lain dia naphthalene. So apa yang berlaku semasa melting? Okay, temperature of naphthalene does not increase. The bonding force increase. The kinetic energy constant. Mana betul?
E.
B. Okay, during melting, temperature of naphthalene does not increase. Okay, remain constant. Dekat kita bagi apa? They remain at the temperature of melting point. Okay, the bonding force is decreases. Okay. Right, 19. Latent heat of fusion. Latent heat fusion for water. Okay. Alright, nombor satu. Is heat absorbed. Tengok heat absorbed. Okay, first, maksud dia tak pernah guna 1 meter cube. It always 1 kg. So, mana yang 1 meter cube potong, 1 meter cube potong. It's always 1 kg. Okay, 1 kg apa? A ke C?
A.
Okay, kalau C ni, apa masalah dengan C?
Sebab that's for specific heat capacity.
Yeah, sebab sini increase temperature, specific capacity. Oh, ya, ada message chat. Apa? Oh. Alright. Okay, so jawapan dia A. Okay, next baru ada kira. How much heat is needed to be supplied to change 500 gram ice block to 0 degree to water at 0 degree? Okay, so temperature does not change. There's only changing state of ice into a water. So basically this is latent heat of fusion. Okay, soalan cikgu, latent heat of fusion being absorbed or being released. Itu soalan dia. It is a latent heat of fusion being absorbed or being released.
So,
Absorbed because solid to liquid. Okay, good. So formula dia apa? For latent heat, it will be Q equals to M L. Data tak ada. Okay. L ni mewakili ni lah, specific latent heat. So masuk saja. So Q sama dengan 0.5 kg times with okay 3.36 10 to the power of 5 joule per kg. So kg cikgu boleh potong. Tinggal joule. So bahagi 2 1.68 kali 10 kuasa 5 bola. Okay, so next one. So korang nampak tadi, specific heat pun tak banyak kira-kira kat paper 1. Kat paper 1 tadi dia tak banyak kira-kira pun. Tadi ada satu je kot soalan kira-kira. Yang lain semua konsep. So kat sini pun kita baru jumpa satu. Okay, diagram show a heating curve of a liquid which statement explain what happened at QR. Okay, apa jadi dekat QR? Okay, ni QR. So tap. Ini temperature of melting point. Okay, which statement explain what happened in QR? Latent heat of fusion is used. No heat is absorbed. Kinetic energy increase. The liquid experience phase change from liquid to gas. Okay, mana satu?
A.
A. Right. Okay, 22.
Cikgu,
Mm-hmm.
isn't that for latent heat of vaporization?
Vaporization.
Sebab dia cakap liquid.
Oh, jap. Heating curve of a liquid. Heating curve of liquid. Oh, maknanya. So, donkey lah. Liquid experience a phase change from liquid to gas. Heating curve of a liquid. Okay. Heating curve of a liquid. So jawapan dia donkey. Experience from liquid to gas. Okay. Okay, 22. Show change state of matter. Okay, so kita tengok dulu A. Ice, negative 1 degree to I, 0 degree. So kat sini, there's a temperature change. And then ice to water. Latent heat of fusion being absorbed. Okay, and then water to water. Okay, water to water, but temperature 0 to 100. This is specific heat. Okay. And then 100 kekal 100, tapi water now becomes steam. Latent heat, vaporization, being absorbed. Okay. Alright, so question is, which change of state matter involve specific latent heat of fusion? So dekat mana specific latent heat of fusion? So based on the question, specific latent heat of fusion, the answer is ball. Okay. Dapat tak?
Dapat.
Okay. So I think it's easier lah for you untuk ni. Okay, next one. 1 centimeter cube of ethanol and 1 centimeter cube of water are poured onto a table. Ethanol evaporate faster compared to water. Okay, maksudnya ini adalah proses from a liquid evaporate meaning to gas. Okay, so kenapa? The density is lower, the mass is smaller, the specific latent heat of ethanol is lower than specific latent heat of water. Okay, the specific capacity of ethanol is lower than specific of water. Okay, so mana satu? Kenapa ethanol evaporate faster? Maknanya ethanol from liquid of ethanol, dia nak jadi gas, dia perlukan only small amount of heat, and that heat kita panggil sebagai specific latent heat. So the specific latent heat of ethanol is lower than specific latent heat of water. So water nak jadi gas, dia kena release lagi banyak, dia kena absorb lagi banyak heat compared to ethanol. Okay, ethanol absorb sikit heat, dia dah jadi gas. Okay. So now kita tengok soalan 2017, nombor 21. Okay, so diagram 18 show the phase change in 4 process, P, Q, R, S. Okay, so process. So the name of the process macam kita ice to water, so S will be melting. Okay, so yang ni water to steam. Water to steam apa? Okay. Right. So kita ambil bawah dulu. Yang ini freezing. Okay. Water to steam kita panggil?
Boiling.
Boiling. Kalau panaskan macam ni boiling. Kalau kita biar je, itu evaporate. Letak air atas meja, dia evaporate. Okay, tapi yang ni boiling. Okay, lepas tu kat sini condensation. Okay, tu proses. Cuma soalan dia, okay, which of the following is matched correctly? Okay, so kita tengok balik kepada soalan tadi. Okay. S dengan Q require heat. So this is absorb heat. While P dengan R release heat. Okay. Okay. PNR, release. QNS, absorb. RNS, okay, salah. Cacing. Itulah dia. Okay, dah masuk gas law. Kejap, kita tengok dulu. Gas law, 1, 2, 3, 4. Lepas tu, paper tu, okay. 4, 5, 6, 7, 8, 9. Okay. Alright. Okay. So, macam tu kita, yang ni kita stop dulu. Okay, kita sambung pukul 10 nanti. Baru enter. Siapa yang enter tu? Trisha. Okay, ke korang nak buat yang ni? Ke kita nak sambung pukul 10? Korang nak sambung pukul 10 ke korang nak start terus yang ni?
Sambung pukul 10.
Sambung pukul 10. Itulah,
Tak
tu sambung pukul
makan
10.
lagi.
Itulah, kita rehat dulu. Korang pergi makan apa semua dulu. Nanti kita sambung pukul 10.
Yeay.
Okey, cikgu.
Okay, tinggal satu lagi subtopik dengan paper tu.
Okey, cikgu.
Okay, alright.
Cikgu, bye cikgu.
Lajunya. Lajunya Alia. Okay, bye-bye semua. Kita jumpa pukul 10. Cikgu bagi link.
Alright.
Okay, cikgu. Thank
Okay.
you.
Thank you, cikgu.
Bye.
Bye-bye. Bye-bye.